So can we do without the microphone, or has he's turned it back on? All right. Well, thank you all for coming out. Thank you to the organizers for inviting us to be here today. You've got some great activities going on, and it's a pleasure to be here with you. I'm going to talk to you today a little bit about the doors that the Space Launch System program can open to discovery. So you've probably seen some version of this chart at least 10 times since you've been here this weekend. NASA is obviously in the business of reaching to new heights to help us discover things that we don't currently know about. And what I want to talk to you today is about the capabilities that the Space Launch System is providing that allows us to go beyond Earth orbit. You've heard, if you've been to some of the presentations, about some of the other NASA centers that have made presentations here this weekend. The Marshall Space Flight Center has been in the business for over 50 years of providing propulsion and transportation systems for the agency. We have been involved in the process of lifting from Earth. We've created both the Apollo and the Saturn program, the rockets, the launch vehicles that made that possible, all the way up to the propulsion systems for the shuttle. You heard in the previous panel about the plans for our commercial partners and how they are providing capabilities for routine access to the International Space Station, which is a great capability, and we are excited to have them on board because it allows NASA and the Marshall Space Flight Center in particular to develop the next space launch capability that allows us to go beyond where we can currently go with the capabilities that we've had for the last 30 years with the shuttle program. The space station is a very important part. If you were here earlier in the week, you saw some of the important research that can come out of that. I spent the first 15 years of my career working on experiments and hardware to fly on the space station, and there is a tremendous amount to be learned from that. But one thing I think you can probably take away from this conference is you have to always be looking forward and what's that next step. So while we'll continue to get wonderful results and things that will impact our ability and discoveries that will help us here on the Earth, it's also very important that we start looking at what those next discoveries can be. I won't go into a lot of detail on this because you've heard it several times. There are multiple things we can do, and if you've followed the blogosphere, you know that there's a lot of conversation about the fact that we're building a rocket to nowhere, but I would tell you we're building a rocket to anywhere. So if you were going to be moving to California, you were coming from New York, you could do it in a car. You'd have to make multiple trips, especially if you were taking furniture. Or you could take a moving van and take a whole lot of stuff with you and maybe only have to go one time. So we're not building a rocket to a specific destination, but we're building a rocket with capabilities that allow us to encompass all the things that we hope to do in the near future. The Marshall Space Flight Center and the nation as a whole has been building exciting, very highly capable equipment and machines that allow us to go beyond the Earth's bounds for many, many years, starting with the Apollo program and then evolving into the shuttle. When we started the shuttle, we knew it would be a very powerful vehicle, but we did not know that it would be a vehicle that for 30 years would provide us with tremendous access to space, allow us to build a space station, launch satellites, and many other things. So likewise, with the Space Launch System, we expect it to be a workhorse for many years, so we're building a capability that will allow us to do that, be very safe, very affordable, and sustainable. And by sustainable, that's not just from a green standpoint, which is what a lot of people think of when they think of sustainability, but it also means being very flexible. Another thing that I find very interesting being a part of the rocket business is that everybody's a rocket scientist and everybody has a design for the best rocket. And yes, indeed, there are 1,000 or more ways to build a rocket that will allow you to do various missions. And we looked at over 1,000 configurations or architectures that would allow us to do some of the capabilities that we needed for future missions. However, there were some things that we had to keep in mind. One, it had to be very safe. Second, we had a launch day. We were trying very diligently to provide a capability that could be available just as quickly as possible. With the gap that we have in between the shuttle retirement and commercial crew being able to get back to space station, we needed something that we could fly just as quickly as we possibly could. So that was another one of the factors. Another factor was that it needed to be low cost, and low cost is relative. Everybody thinks that obviously it's a very big investment for the taxpayers, and it's very important that we provide as much value and benefit as we can. And at the same time, during the congressional budget processes that we are under, it's very important that we show good value and that we be able to do it within the resources that have been allocated to us. If you heard Alan Ladwig this morning, it's 0.5% of the national budget is focused on the entire NASA budget, and this is just a very small fraction of that. So we had to come up with an architecture that allowed us to be as economical as possible. So one of the things that we were able to do, it was to be able to reuse and repurpose many of the national assets that we already had as a part of the space shuttle system, and then we also leveraged some of the work that we had done previously for the Ares rockets in the Constellation system. So we're using the solid rocket boosters that were in development for the Ares program. The space shuttle had a 4-segment booster. We were in the process of developing a 5-segment booster to give us some additional lift under the Constellation program. So we are using that technology and being able to use that as part of our architecture for the first launch. ATK has been a long-standing partner of ours for building the solid rocket boosters, and they are our prime contractor for that part of the vehicle. In addition to that, we have been using space shuttle main engines for 30 years. There have been some developments, some improvements on those, and they've been extremely reliable and a very strong workhorse for our space launch program for many years. So we will continue to use what's called an RS-25, or the Space Shuttle Main Engine, for the first 4 flights. We have enough engines. We currently have a configuration that uses 4 engines on each flight. That'll be at the bottom of the core stage, and so those engines, we have enough in the current either flown or development engines that could be very easily certified for us to fly for 4 launches. In addition to that, we do have a new development program for the core stage. It's a slightly different configuration from the shuttle. However, we are able to use some of the materials, the processes, as well as the manufacturing tools and the facilities that we use to build the external tank for the shuttle, also making it much more affordable. You heard earlier, ULA is providing us with the interim cryogenic propulsion stage, and that is something that will allow us to have our first launches very quickly. And then as we evolve to a heavier lift capability, we will be developing a heavier lift upper stage. That will include the use of a potentially new engine, the J2X. All of our engines are provided by Pratt & Whitney Rocketdyne. So as you can see, while there's different terminologies used for commercial, the Space Launch System is certainly a very strong partnership with industry and involves a lot of commercial endeavors. Our initial capability will be for 70 metric tons and then evolvable to 130. Another one of the technologies that we recognize there is a lot of development work going on in is advanced boosters. So while we've currently been using solid rocket boosters, there are a lot of people out there that believe that liquid boosters are potentially a good way to go for the future. So within the next few years, we will have a competition to determine which is the best technology. We currently have awarded 3 contracts and a 4th under negotiation for work on advanced booster risk reduction and demonstration, so that we're working on some of those technologies that will allow us to go further and evolve to that 130 metric ton capability. So we talk about big rockets, and everybody's got their version. You know, we've got a lot of wonderful commercial rockets out there that can do a lot of very reliable, repetitive launches. But when you think about how large this rocket's going to be, it just opens up a whole genre of capabilities that we've not been able to access in the past. Anybody out there, was anybody able to go watch a shuttle launch? A couple of people. If you ever got very close to it, you realize that it was a very large vehicle. Well, the 130 metric ton vehicle will be almost twice as large as this, or more than twice as large as the space shuttle was in terms of height. I noticed one of the other charts, someone had elephants. Well, we probably won't be launching any elephants, but it does give you kind of a visual when you think about the fact that for our initial launch, you'd be able to carry, be able to lift the weight of 12 elephants, and then for the 130, that's 22 elephants. And I don't know about you, but that's a lot of weight. The vehicle itself will weigh a lot, between 7 and 8 747 jumbo jets. And then if you look at how powerful that is, and I've just been told that obviously kids these days don't even know what a locomotive is, but that Corvettes are probably not really cool anymore, so we've got to update our chart. But when you think about the amount of power that's behind this rocket, over 160 for the smaller vehicle, and then 208 Corvette, or 208,000 Corvettes, so that's a lot of lift and a lot of power. And what's so advantageous about being able to do this is what it allows us to be able to do. You've heard a lot about satellites today as well, and many of the wonderful satellites that we have are sometimes hindered by the fact that they have to produce origami type structures where you have to fold up solar panels and things like that in order to make them fit within the volume of the launch vehicles that the satellites ride on. So one of the advantages is we have a much larger volume, so we can build telescopes with larger mirrors. We can build solar panels that are larger and don't have to unfold as much, so you reduce the risk of having those satellites or the solar panels not expand correctly. So just a tremendous capability for the nation. We talked about the solid rocket boosters. They are built out in Promontory, Utah. This is a test, shows a test from 2011. Back during the Constellation program, we did 3 development motor tests, and then just this month, we completed the final casting, the final 5th casting of the segments for the qualification motor, and that testing will begin to start in 2013. So you can see we have hardware that is being produced and tested as we speak today. And on this next slide, you can see there's kind of some flowers down here in the bottom of the screen. If you'll watch those as we start the video. Get the sense for the power and the amount of energy that's coming out of these solid rocket boosters. Those actually allow us to fly during the first 2.5 to 3 minutes of the flight. So that's the initial lift that gets us off the ground. As I mentioned, you can see the solid rocket boosters on the, that would be left side for you of the screen. That's from the shuttle program, and then as you see the Space Shuttle main engines, or the RS-25s, were the core that were integrated into the bottom of the shuttle orbiter. This time they'll be integrated into the bottom of the core stage, which will be a liquid oxygen and hydrogen stage. One of the other things that we're also doing to preserve our ability to fly early as well as be more economical is use a dual controller, a common engine controller for both the engines that control the core stage, the RS-25s, as well as a potential J2X for the upper stage. One of the things that you get into when you use heritage hardware is that some of the components, particularly for the shuttle, those were many of the brains of the engine controllers were built as many as 30 years ago. So you run into obsolescence problems and you have trouble with vendors, plus the reliability, the speed is so much better now. So we had begun development of an engine controller for the J2X upper stage engine under the Constellation program. And come to find out, by replacing just a couple of cards on that controller, we'll be able to control the J2, the RS-25 engines as well. So this will allow us to have a dual-use controller that we can change out cards on, be much more economical and much more reliable because we'll have the same parts, the same vendors, and allow us to get to flight even faster. We have begun testing that controller at the Marshall Space Flight Center. So that is another piece of hardware that is rapidly in development and on target for delivery. So this is a picture that shows the inside of the J2X upper stage engine. That's been in development for several years now based on early constellation work. It's been a very, very good engine. The performance has been extremely good on this engine. One of the things that has been record-setting was the number of tests that it took to get it to 100% full power. As we start new engine testing, we gradually ramp up the amount of power and throttle that's behind that engine. This engine reached that in only 4 tests, and then we were able to reach a full duration for that engine test at 100% power in only 8 tests, which is orders of magnitude less than other development engines. It is one of the first engines that's been developed in this country by Pratt & Whitney in a number of years, so it's a great accomplishment for the nation. Shows one of the tests at the Stennis Space Center. Keith Brock this morning talked about the excitement of being out there for one of those tests. If you're ever in the Mississippi area, I-10, right off of I-10, the Stennis Space Center has a visitor center, and you can go watch one of those tests. So it's exciting to be a part of that and know that we're making great progress. It's a great capability that the nation has, and we're using our infrastructure and our assets across the nation. So where are we going? Our first 2 flights have been approved. The initial mission will be with the Orion spacecraft on board. It will just be a test mission of a trajectory around the moon. The primary function of this mission will be to test the reentry. The ULA guys also talked about an EFT-1 flight, engineering test flight number 1, which will be in 2014, which will also allow them to get some early data. But this will be able to demonstrate the ability to re-enter at the speeds that are required prior to doing it with actual crew on board. So we are ready, we'll be ready to do our second flight in 2021 once the Orion is ready for a crew certified capability. To talk a little bit more about the Orion program, since there was no one here this time to represent them, it is the portion of the vehicle that will be responsible for transporting the crew, a very critical part, especially if we're going for long duration missions. You can imagine all the systems, the environmental control and life support systems that are required to take us on long duration missions. It does have a launch abort system that allows it to be pulled off of the rocket should anything go wrong prior to jettison of the crew module from the rocket. It is equipped with a service module that provides the power and needed support for the mission until the crew module is separated. There is as a part of that, well, you can see the crew module be able to carry up to 6 astronauts. And then the spacecrafter adapter is something that we are also building at the Marshall Space Flight Center with industry partners, and that is a connection between the crew module, the service module, and the launch vehicle itself. So that provides us with a step down in the diameter from the crew vehicle down to the launch vehicle size, as well as provide protection for the service module during the launch. We will launch from the Kennedy Space Center. This is an important part of our program. We work very closely with both JSC as well as KSC on the interfaces between the rocket, the crew module, as well as the launch vehicle. We are reusing the mobile launcher that was begun to be developed during the Constellation program. So work continues on making sure those interfaces are mapped to the current design that we have for the Space Launch System. So I've talked a little bit about the other centers that are involved in this program, but there are just a number of contributions that we get across the agency to the building of the Space Launch System. Our Ames Research Center, as well as Langley, provides us with expert advice in aerothermal types of environments. We have wind tunnels at the Langley Research Center. We have some very small ones at Marshall, so we feed some initial data to them and then do larger scale testing at Langley. Langley and the Glenn Research Center are also very involved in the development of the payload and spacecraft adapters, as well as the fairing that would go in between the spacecraft and the launch vehicle in order to provide some cargo and some extra volume for carrying cargo missions. The Machute Assembly Facility in Louisiana is where the majority of the structural work will be done for the large core stage tank, which is like the old external tank from the shuttle program. The Stennis Space Center we talked about is where engine testing goes on, our large-scale engine testing. Johnson Space Center, of course, is responsible for the Orion multi-purpose crew vehicle, and then our launch site at Kennedy Space Center. Goddard, believe it or not, is also involved in that. They may be one of our customers. We are very much interested in being able to provide the capability for reliable launch for large science payloads in the future, and so as they begin to look forward as the kinds of robotic missions that we want as a nation, then they look to us as a potential for a great way to get up into space. But it's not just about the civil servants and the contractors that work at each of these NASA centers, but I wanted you to also be aware that as a student we have prime contractors and subcontractors that are helping us build this vehicle. As you can see, there is coverage across 34 states across the nation, so it's a great effort across the entire nation to help us bring this launch vehicle to be. You've talked a lot about some lofty visions for the future as a part of the SEDS organization. I think that's great to see you all thinking that way. This is a national capability for America, and it is a huge part of our future. We are able to do everything from deliver satellites for national security purposes to thinking about the unbelievable number of technologies that have come out of the space program. We have to develop new technologies in order to be able to do these advanced missions, and much of that technology finds its way back to the United States, back here on Earth, into our everyday lives. Scientific knowledge can be gained by sending humans. You've heard wonderful talks this week about things that we can do on other planets, the things that we can learn about our own planet by learning how the solar system evolved. And it's, down to the economics of it, it's about jobs, and it's about creating jobs. It's also about the industries and the commercial industry that develops as a result of this. So while there's a very small amount of money that comes to the government to build vehicles and structures like this, the economic benefits to the entire country are much, much greater than that small investment. And we also have global partnerships. We're looking particularly in the area of bearings and adapters. Many other countries have launch programs, and they have built other dimensions for bearings and for adapters, and we want to make sure that we leverage capabilities that are already out there and make the best use of those and don't reinvent the wheel where we can. So I hope you've been able to see from this that the Space Launch Vehicle is a capability to anywhere. It'll be the most powerful rocket that's ever built, and we're basing it on knowledge that we gained from the Saturn and Apollo programs as well as the shuttle programs. There are key infrastructure across the nation that we're utilizing to make it as functional and as economic as we can to open the frontiers for discovery. It will be safe, and it will be affordable, and it will be the backbone for many discoveries for the near future. How can you be a part of it? For the first time in a long time, NASA is hiring. We talked about the ability to work for possibly one of the contractors, but this is a very easy way. USA jobs.gov is a way to monitor for your particular geographic area things that you may be interested, openings. We do also have, I talked with a gentleman earlier, we do have a co-op program as well as intern programs over the summer. So your level of interest and your ability to be able to be a part of this program is at your fingertips. So there are great websites that let you look for those opportunities. To get more information about the Space Launch System, you can go to nasa.gov/SLS. We do have a Twitter and a Facebook account, and we are also on YouTube. You can see a lot of the different activities and tests and things that we're doing on a daily basis on YouTube. The next slide, I'm going to start a video that I hope will kind of wrap all this up for you and give you some more ideas as to the great things and the great doors that this vehicle will open for the entire nation and for our knowledge for the future. It'll show you a little bit about some of the people and some of the work. We do have real hardware that's being built, and this will kind of show you for all three programs, for both the Orion, the Space Launch System, as well as the work that's being done at our launch site at Kennedy. you can tell that I'm very excited to be a part of this. We have a long way to go, and we need you to help us. So I hope you'll keep promoting the use of space. It's an exciting thing to be a part of, and hopefully you can go there with us. So at this point, I'll leave you with opportunity for questions. Anybody has anything? Yes.
Hi, Lars Osborne, Montana State alum. Thank you for coming to SpaceVision, first of all. And my question was, what do you think that SLS is a better program than Constellation? And if so, what makes it better?
That's an extremely good question. As I mentioned early on, there are 1,000 ways to design a rocket, and depending on the constraints that you're given, you pick the one that meets the best and has the best of all possible solutions. I think one positive thing about the architecture that we currently have is the fact that you can fly crew or cargo on it. So we're building one vehicle and can use it for multiple purposes. We're also leveraging a lot of heritage hardware, at least for the early design phases. So I think that will give us a very reliable vehicle very early on and get us flying again, with an ability to then use some very common hardware, including the tanks. The diameters are the same, the tooling will be the same. And so it'll allow us to build a more evolved and more capable vehicle much earlier, and with a lot more economy of scale as well as funding. So I don't know that one is any better than the other, but there are certainly advantages to the current architecture that we have now. Okay, other questions?
I'll go, Sharon. It seems clear that for at least the next decade we're going to be using chemical propulsion, and probably far beyond that. But as we heard this morning, there are other options in the pipeline, and I know NASA's probably working on researching those for the long term, but are there any substantive plans to use things like nuclear electric rockets and really work on the weight, the cost-to-weight ratio to get the weight of these rockets down?
Another good question. NASA has for a long time been doing a lot of research on other types of propulsion, including nuclear electric, solar cell, all types of different propulsion technologies. The current technologies that we have, while maybe not as effective from a weight ratio, are very reliable and very well understood. And because we are currently in the need to get a vehicle flying again quickly, we're focusing on that. But there are groups of researchers at NASA that are looking at all these other propulsion technologies. Many of those are being looked at for robotic missions initially until we work out some of the technologies. So we are always looking at the next steps, and obviously some of these propulsion techniques will get us there a lot faster and a lot more efficiently. But at this point, the cost investment to make those operational we just don't have that kind of funding level.
I was just wondering how easy it is or hard to change I know you have the same tooling for the core stage, but how difficult is it to change for the new loading? It's going to be top loaded instead of the side.
For the new what? I'm sorry.
For the core booster, how involved is it? Is it just got to tweak some things to have a top mounted payload?
Well, the core stage is a completely different, I won't say completely. It is a very different design from what we had with the external tank from the shuttle, because the engines are integrated into the core stage. Then of course we also have to have the adapter and the connectivity to the crew stage on top. So it is a little bit different design. We are, however, able to use many of the alloys, the welding techniques, the assembly techniques. We will be buying new tooling for the machine assembly facility, because this is a much larger and longer tank than we had for the shuttle. So it is a different design. It is we have a different contractor. Boeing is our prime contractor for the core stage. But we are able to reuse a lot of the technology development that we did on the shuttle in order to build that stage.
Hi, my name is Emily Knoll. I'm from Iowa State University, and my question for you is, do you think it's more like, I mean, I guess what would happen first to you, like in chronological order? Would they go to an asteroid or Mars? What's more likely to happen first?
As has been mentioned a few times this week, that's a policy decision. We're currently building a capability that allows us to go to both. There are camps that are interested in both for various reasons. There's a lot to be learned from asteroids. We can learn about the potential for planetary protection of capturing an asteroid, destroying it. There's a lot of interest in going back to an asteroid. Going to Mars, there's a chart that I had. Going to Mars is orders of magnitude beyond what we can currently do. So asteroids and Mars are kind of in the same. Let's see if I can get back to that chart. And the screen goes out, so I can't see. Okay. So the asteroid belts are various ones that are of interest that we could actually land on, or an order of magnitude closer than Mars. That's still not saying a lot because they're 3 million miles away. So it's a stretch, but every progression that we make, we learn things. One of the things that's a potential that might be of interest early on is going to a Lagrange point. There's a lot of interest in going there because it's a low energy well, and it's much easier to stay into that area, and so we can learn a lot about living off the planet or the moon. So you could potentially have a habitat there. That also goes to the commercial aspects. It would be of interest to a lot of people to have a commercial habitat there where you could have space travel and a hotel in space. So it's probably likely. I mean, there's all different scenarios. The agency has not yet decided what the first destination will be, but I will just say that going to the asteroid belt is a little bit closer than going to Mars, a little bit easier mission. So if you're looking at just progression of phases and steps, it's probably likely you would go to an asteroid first. Okay.
This is Chang from the University of Tokyo. I'm just curious that why do you use the same system to launch manned craft and the cargo craft? Why do you use the solid rocket boosters for both purpose? And is the solid rocket booster necessary for both systems? Why is that, and why wasn't it?
Okay. The first question. We are flying, we have the capability to fly crew and cargo. We can also fly the first vehicle without the crew and just have a large cargo mission as well. So you can do either. The choice is because it gives you a capability to do both, and so by building one vehicle, you can launch crew and cargo. A small amount of cargo when you launch the crew, not nearly as much as if you didn't have the crew. But you can launch both or either with the same vehicle, so that's much more economical design. The solid rocket boosters were chosen initially to get us to an early first flight because that's heritage hardware that we already have. A number of those, we have enough to do 4 flights of that as well. However, for the 130 metric ton, we have a competition, we are looking at the possibility of using liquid boosters, advanced boosters for that mission. We realize that is a preferred technology by some people. So we're looking at developing and evolving the technologies that are required to make that a reliable and a mature technology that we will consider for the 130 metric ton vehicle. So a decision has not been made yet as to whether to use solids or liquids for that evolved vehicle. Okay, anybody else? Well, I just want to thank you very much for coming today. I know this is the end of your day and you've got a banquet ahead of you, so I really appreciate your interest and look forward to maybe seeing some of you guys in the future. Created both the Apollo and the Saturn program, the rockets, the launch vehicles that made that possible, all the way up to the propulsion systems for the shuttle. You heard in the previous panel about the plans for our commercial partners and how they are providing capabilities for routine access to the International Space Station, which is a great capability, and we are excited to have them on board because it allows NASA and the Marshall Space Flight Center in particular to develop the next space launch capability that allows us to go beyond where we can currently go with the capabilities that we've had for the last 30 years with the shuttle program. The space station is a very important part. If you were here earlier in the week, you saw some of the important research that can come out of that. I spent the first 15 years of my career working on experiments and hardware to fly on the space station, and there is a tremendous amount to be learned from that. But one thing I think you can probably take away from this conference is you have to always be looking forward and what's that next step. So while we'll continue to get wonderful results and things that will impact our ability and discoveries that will help us here on the Earth, it's also very important that we start looking at what those next discoveries can be. I won't go into a lot of detail on this because you've heard it several times. There are multiple things we can do, and if you've followed the blogosphere, you know that there's a lot of conversation about the fact that we're building a rocket to nowhere, but I would tell you we're building a rocket to anywhere. So if you were going to be moving to California, you were coming from New York, you could do it in a car. You'd have to make multiple trips, especially if you were taking furniture. Or you could take a moving van and take a whole lot of stuff with you and maybe only have to go one time. So we're not building a rocket to a specific destination, but we're building a rocket with capabilities that allow us to encompass all the things that we hope to do in the near future. The Marshall Space Flight Center and the nation as a whole has been building exciting, very highly capable equipment and machines that allow us to go beyond the Earth's bounds for many, many years, starting with the Apollo program and then evolving into the shuttle. When we started the shuttle, we knew it would be a very powerful vehicle, but we did not know that it would be a vehicle that for 30 years would provide us with tremendous access to space, allow us to build a space station, launch satellites, and many other things. So likewise, with the Space Launch System, we expect it to be a workhorse for many years. So we're building a capability that will allow us to do that, be very safe, very affordable, and sustainable. And by sustainable, that's not just from a green standpoint, which is what a lot of people think of when they think of sustainability, but it also means being very flexible. Another thing that I find very interesting being a part of the rocket business is that everybody's a rocket scientist and everybody has a design for the best rocket. And yes, indeed, there are 1,000 or more ways to build a rocket that will allow you to do various missions. And we looked at over 1,000 configurations or architectures that would allow us to do some of the capabilities that we needed for future missions. However, there were some things that we had to keep in mind. One, it had to be very safe. Second, we had a launch day. We were trying. So can we do without the microphone, or has he's turned it back on? All right. Well, thank you all for coming out. Thank you to the organizers for inviting us to be here today. You've got some great activities going on, and it's a pleasure to be here with you. I'm going to talk to you today a little bit about the doors that the Space Launch System program can open to discovery. So you've probably seen some version of this chart at least 10 times since you've been here this weekend. NASA is obviously in the business of reaching to new heights to help us discover things that we don't currently know about. And what I want to talk to you today is about the capabilities that the Space Launch System is providing that allows us to go beyond Earth orbit. You've heard, if you've been to some of the presentations, about some of the other NASA centers that have made presentations here this weekend. The Marshall Space Flight Center has been in the business for over 50 years of providing propulsion and transportation systems for the agency. We have been involved in the process of lifting from Earth. We very diligently to provide a capability that could be available just as quickly as possible. With the gap that we have in between the shuttle retirement and commercial crew being able to get back to space station, we needed something that we could fly just as quickly as we possibly could. So that was another one of the factors. Another factor was that it needed to be low cost, and low cost is relative. Everybody thinks that obviously it's a very big investment for the taxpayers, and it's very important that we provide as much value and benefit as we can. And at the same time, during the congressional budget processes that we are under, it's very important that we show good value and that we be able to do it within the resources that have been allocated to us. If you heard Alan Ladwig this morning, it's a 0.5% of the national budget is focused on the entire NASA budget, and this is just a very small fraction of that. So we had to come up with an architecture that allowed us to be as economical as possible. So one of the things that we were able to do, it was to be able to reuse and